A line with slope m, and it goes through the point x1, y1. So we know its slope, and we know it goes through a particular point. The equation in point-slope form is y minus y1 equals mx minus x1. The x1 and the y1 are from the point. And m is the slope. So point slope form is really nice, really easy to use, because we don't have to do a bunch of stuff to the equation. And we don't have to, if we have a point and a slope, we don't have to find, we don't need the y-intercept. We don't need to find b, which on the, we remember from the last problems on the first side of the worksheet yesterday, sometimes finding b is not the funnest, most fun thing to do. And in the future, if you go further in math, if you go on to calculus, often you'll have problems where you figure out the slope and you have a point, and you can write the equation of the line really easily. All right, are we good with point slope form? So let's look at a quick example. I'll leave this here for people who need it. So we want an equation of a line with slope -1/3 that goes through 1, -4. So here's how I'm going to suggest that you set up your equation for a line with point slope form. We're going to write y minus blank equals the slope, -1/3, and then parentheses x minus blank. And we fill in the blanks from the point. So this is x1, y1. So I'm going to take this. I'll do a highlighter here in blue. I'm going to take y1 and put it here. So I'm just going to put this number there, -4. And I'm going to take x1. I'll highlight that in red there. Whoops, no. I wanted to highlight that in red. So there we go. Highlight that in red. I'm going to put that there. So that is going to be 1. There's my equation of the line. Y minus -4 equals -1/3 x minus 1. And I'm done. I could write this, if I wanted, as y, change my color here, y plus 4, because y minus -4 is y plus 4, equals -1/3 x minus 1. And I don't need to do anything else with that. There's an equation in point slope form. So our equation y minus blank equals a slope times, in parentheses, x minus blank, and we fill in the blank from our point. Isn't that nice? All right, let's look at another example. Let's say we want to graph an equation of a line in point-slope form. Say we want to graph y plus 3 equals negative 2, x minus 2. Now, when I see a y plus 3, I'm going to think of this as y minus negative 3, because our point-slope form is y minus y1 equals mx minus x1. So I'm going to think of this as y minus negative 3 equals negative 2, x minus 2. Well, this is our slope, is negative 2, and I'm going to think of that as negative 2 over 1, so I have a fraction. And a point on the line is 2, negative 3. This is this number, and this is that number. So I'm kind of I'm pulling the numbers from the blanks here and putting them in my point. And now to make my graph, I'm going to start at the point that I know is on the graph, and then I'm going to count from that point using the slope. Count, rise over run. So my point is 2 over 2 down 3. So there's 1 point. And I'm going to count rise over run. I'm going to count down 2 over 1. So I'm going to count down 1, 2, and go over 1 to get my new point. And there are the points that I can use to graph my line. So to graph it, I started at the point. And then I counted rise over run for new point. So I counted down 2 and over 1. I know it needs to go downhill because my slope is negative. So it's a lot like graphing in slope-intercept form, but instead of starting at the y-intercept and counting with our slope, we start at the point that they give us in our equation and count rise over run with the slope. Yes?
I'm a little confused. What's the point of having the equation? Like, what does it do, I guess?
A lot of times in applications, you know the slope of a line and you know a point that it goes through.
Yeah.
So having the equation like this, it's just an easier way to write the equation when you have a slope and a point rather than y equals mx plus b. It's just another way of writing an equation of a line that's different than y equals mx plus b. Okay. That can be useful in certain situations. Yes? Yes. All right, let's look at another example. This example is like the problems we did on the bottom of the worksheet yesterday. But we're going to use point-slope form today. So we want to write an equation of the line through negative 2, 1 and 4, 4. So we know we need to find the slope. So I'm going to say m equals, I'm going to label my points, x1, y1, x2, y2. Doesn't matter which one is 1 or 2, just the 1's have to stay together and the 2's have to stay together. y2 minus y1, 4 minus 1, over x2 minus x1, 4 minus negative 2. Well, 4 minus 1 is 3. 4 minus negative 2 is 4 plus 2, 6, which is 2. So there's my slope. To write my equation, I can pick either point. I can pick either point. So I'll pick this first one. Y minus blank equals the slope to x minus blank. I'm going to fill in the blank with the x and the y from this first point. y1, y minus 1, x1, x minus negative 2. Yes? 3 over 6 does not equal 2. Well, 3 over 6 equals 1/2. Thank you. I told you before, right, that I do that on purpose to make sure you're paying attention. So 2 people were paying attention. Thank you very much. I can leave the equation written just like this. I would be fine if you left it written exactly like this. Now, usually we would say y minus 1 equals 1/2 x plus 2. Just minus negative is positive. Well, sometimes the problem will ask you, write 2 equations. My second equation is y minus blank equals the slope, 1/2 x minus blank. I'm going to fill in the blank from the other point. Well, y is 4 and x is 4. Both of those are the same equation. Either one of them is fine. Well, what if we wanted y equals mx plus b form? All I need to do, I'll do that in blue. I'm going to say y minus 4 equals, I'm going to distribute here, 1/2 x, and what's 1/2 of negative 4? Negative 2. And then I'm going to add 4 to both sides. And I get y equals 1/2 x plus 2. Would I get the same thing if I did this equation? Well, let's see. I'm going to do y minus 1 equals 1/2 x. 1/2 of 2 is 1. I add 1 to both sides, and I get y equals 1/2 x plus 2. I get the exact same thing in y equals mx plus b form. Either way, for either point that I use. Isn't that nice? Yeah. Isn't this an easier way to write the equation of the line than we had to do at the bottom of the worksheet yesterday, where we had to find b for each of those things? Just fill in the blanks here, and you're done. All right, let's look at one last example. What if we had a table? And let's say that where the table represents the hours we work and how much money we make. 5, 130, 10, 210, 15, 290, and 20, 370. And we want to write an equation. Well, let's think for a second about how we would do this. We need the slope, but each of these is a point. We can think of this as an x and a y. So we can choose any of these points to use to write our equation. How do we find the slope here? From a table, yeah? We would find out the changes, right? This is going up by 5, 5, 5. This goes up by 80, yes? 80, 80. So the slope is 80 over 5, which is, I think this is correct. Check my arithmetic. 16. Is 80 divided by 5 16? I think so. The slope is 16. So my equation, I'm going to say y minus blank equals the slope, x minus blank. And I'm going to fill in that blank with any x and y from the table. So I can say y minus 130 equals 16 times x minus 5. There's an equation of the line. If we wanted to put it into y equals mx plus b form, I'm going to distribute here. And I would say y minus 130 equals 16 x minus.
Good morning, staff and students. Please excuse the interruption. Within the first 60 days of each school year, all schools in the state of Colorado are to conduct an emergency lockout and lockdown drill. Today is our day that we're going to practice this. And so we're going to do a two-part drill today. They're separate, but they're going to be running consecutively.
And there's our answer.
Our first drill is going to be a secure action drill, otherwise known as a lockout. The goal of this particular drill is to bring everyone inside and to prevent anyone from entering or exiting our building. Outside doors will remain secure, and doors or locks to prevent unauthorized entry into our building and to keep the original equipment outside and away from our staff.
All right, our homework, just so we have it up here, is on page 318, number 8 through 26 even, and number 27. And this is section 5.4.